Okay, let's see question 1. To find A, it is simple. Integrate the joint PDF of x, y, and we can find that the 4 over A is 1, so we can get that 4A is equal to 4. Okay, question 2. Question 2 and 3. To find that if x and y are uncorrelated and independent, so we can get to find the ex and the ey and the exy. First, ex, we can find to integrate the CDF of xy, we can find that ex is equal to 0. And similarly, we can find that ey is also equal to 0. And then the joint mean value of x and y, it is equal to, we can see that integrate xy times 1 minus xy over 4, and the outcome is 1 over 9. So we can find that exy is not equal to ex times ey, so we can get that xy are not correlated, and then we can get that xy, they are not independent. Okay, the last question. To find the joint density function of x squared and y squared. Here we can relate z to be x squared and omega to be y squared, and then we can get that there are 4 roots of the function that z is equal to x squared and omega is equal to y squared and x is equal to there are 2 roots of that z is equal to x squared and the 2 roots for omega is equal to y squared. So, and then we can get that the jxy, it is equal to 4xy. So the joint PDF of z omega, it is equal to that 1 over 4 the square root of z times the square root of omega times 1 over 4, and then we add these 4 roots together, and finally we get that the joint PDF of z omega, it is equal to 1 over 4 the square root of z times the square root of omega, and then we can find that the marginal density function of z and omega. So first, the PDF of z, it is equal to 1 over 2 times the square root of z in the interval of z at from 0 to 1, and similarly we can find that the PDF of omega is equal to 1 over 2 times the square root of omega for the interval of 0 to 1. So we can get that the PDF of z, the joint PDF of z and omega, it is equal to the product of the PDF of z and the PDF of omega. So we can get that x squared and y squared, they are independent.